And just looking back, I'm curious, again, like everything you've learned since, when you look back on Quantopian, are there, 2 or 3 like really important turning points that you can see that maybe, there's a tenet that you have now that we didn't apply, or, something maybe that we did apply and went well, or, what you took away, and what you see as like kind of the key turning points for Quantopian?
Yeah. So for me, I've been extremely positively influenced by Quantopian and in PyMC Labs.
Hi everybody, welcome back to the Quantopian Show. I'm very excited today to have an old friend visiting, Thomas Wiecki, who was one of the very first employees at Quantopian. And a little bit of a story, actually, how we met. I was, no office, no team, no software yet, and I actually had a little bit of a backtester. And I had met Wes McKinney, and I was asking him advice on like who would be a great person to get on the team to work with, and he introduced me to Thomas Wiecki while you were doing your PhD at Brown in psychology, which turns out is all about building models and doing statistics. And then we started collaborating together. So I'm really excited to have this conversation. There's a bunch of things I want to talk to you about. Definitely Quantopian, definitely your new company, PyMC Labs, which is an amazing story we've gotten to talk about a lot offline. And what you think the future holds. So thank you for being here.
Very excited to be here. Yeah, thanks for having me.
Yeah, this is great. I'd like to start with hopefully a big question so that we can hear your thoughts on a lot of things. And back when you were at Brown, I can't remember what year you were in your PhD, but you were kind of more than halfway through, right?
Yeah, second, third year.
Yeah. You got this random call, random introduction. Why on earth did you join Quantopian?
Yeah, I remember that it was a very deliberate effort for me to explore options outside of academia. So
Okay.
I love academia, but I knew that was like a rocky career path. So I was like, okay, well, what else is out there? And I never worked in industry, so I thought, well, what is that even like?
Yeah.
And that was also at that time when data science exploded with that big article, the sexiest job of the 21st century. And then, as you already said, like psychology is all about doing models. So I realized, oh yeah, that's already what I'm doing. And then, it was reaching out to people, getting to know Wes, and then through that you. And I mean, for me, it was like, I couldn't believe my luck. Well, like, I got on a call and you were super chill. You were wearing that brown shirt to like build rapport. And then quickly after that call, you were like, hey, yeah, let's work together. I'm like, really? Like,
It's that easy.
It's that easy. I just like sort of get to know people, and then here we are. But yeah, very early on, I was amazed by that it wasn't this corporate nightmare that I know people in academia like to make it out to be. That was just like, people doing really cool projects in a laid-back, fun environment, and that's what I fell in love with.
How did you dive into quant finance? Like how did I'm trying to remember. I actually can't remember how you got started. I remember our first conversation and thinking like, this guy's like a perfect fit. It's gonna be fun to work with him. But how did you get started learning about quant finance? Because tons of people are in a similar situation where, for whatever reason, they end up interested in finance, and they have really great training in model building and statistics, but they're new to the financial world. So, what was it like for you? Where'd you start? What would you do now, knowing everything you know now?
So, I did find it simultaneously easy and difficult. So easy because a lot of the concepts at the core are just statistics, applied statistics, and at the end of the day, you're still on linear regressions, and then the interpretation is different. So I didn't find it difficult to really map my existing knowledge of data science statistics to quant finance. So a lot of it was just renaming certain terms.
Mm-hmm.
What I found difficult or more difficult was really to figure out how do people in the industry really build signals, for example? Like, what is all that logic about? Because, and the main reason for that is that I just didn't really find good resources.
Yeah.
So now I guess there's more books like at Quantopian, we then like worked through quite a few of those books and then really built that up. So I really like the book by Lopez de Prado when it came out. And then, of course, well, a lot of the materials that we at Quantopian developed and being able to really play around with things and trying it out, and that I think were the best resource at that time that I found.
On that note, do you think of yourself as a person, like your learning style, do you like to try things and experiment and learn that way, or do you like to sort of read the authoritative sources? Like, do you go back to like original paper? Like, how do you think about learning a new field?
Yeah, I definitely just try
jump
stuff out. And I don't really have a lot of patience for like reading through long books, so that's why we did reading groups that sort of help with that. And also, like, I do think that's valuable, but for me, I just learn way less effectively that way, because also, especially when you're starting out, it's sort of a difficult position because there's all these things and you don't even have the knowledge to evaluate whether something is a good resource, right? You just have to take it on faith, and then you work it through, and then maybe it seems really relevant, but then 2 years later, you're like, well, actually, that wasn't all that good stuff. So that's why just, playing around with things, I just find it much more interesting. And then I also understand them at a much more fundamental level and find out why things make sense in a certain way, rather than someone telling me it's like, oh, well, actually, why do I want to look at alpha and beta, right? Well, if you develop a strategy and you find like, oh, well, it's just tracking the market, that's not that interesting. Okay, well, then I really have this more needs-driven learning and might then look up resources, right, when I encounter a problem, rather than just like, oh yeah, here's like everything you should know, and it doesn't apply really.
Right. One thing I'm curious about though is I'd love to talk to you about areas of your expertise, because you have a real gift for explaining them succinctly and making the ideas like very tangible. So when I'm learning stuff, and I love to experiment also, I'm like a big tinkerer, so I'll just like play with things and go in a lot of different directions. And I think what's a hard step is then to sort of synthesize everything into conclusions. So I was wondering, like, is that something you do explicitly, or does it just sort of happen over time for you? Because it's kind of magical, right? To think that you're like playing around and then all of a sudden you have this like really clear explanation about how things work.
Yeah, that's always a process that it feels very important in a way. I feel like almost I have a very high threshold for allowing myself to feel that I understood something. So I really need to understand it at an intuitive level. Like if it's just a formula and it's just like, well, that's the formula and that's when you use it, that's not good enough for me. Like I really need to understand what each thing is doing and come up with analogies. And what I found over the years is for a lot of people that's good enough, and they would think that they understood it. What was really helpful to many people is, so when I understand these things at a very fundamental level, at that point, I almost find a language that I think is much easier to explain things by. And I almost always think like, oh, so that's what they were trying to tell me. Why didn't they just say it like this? Like that's so much easier. That happened like with math in undergrad. And what I found is like when I then explain it to other people in like those simple terms using analogies and just like not throw away the math and just like, well, just think about it and intuit why that makes sense. And then you get to the math. That I found to work really well. And,
even though you sort of go through it the opposite way, like you go through the math until you find the intuition.
Because there's no one telling me the intuition. So I have to like go through the painful path. Then I can communicate the shortcut.
What is it about having that like intuitive understanding that drives you? I mean, you see, it's a lot of work, right? It's not easy to go through the details of something like Bayesian statistics and all the solvers and like really understand them. What is it that like propels you through it? Like why do you have that urge?
Yeah, it's a good question. I find it inherently unsatisfactory if I don't really
So
understand.
it's more like discomfort with like the state of not having it.
Yeah, exactly, and almost like an obsession to like sort of work on it until I figure it out, and then if there's something that I want to understand but I don't, I just think about it a lot and experiment around with it, and then when it does click, I mean that moment I find extremely satisfying. Where I'm like, okay, and then it's all of a sudden feels so obvious, but it wasn't obvious before. And then the other thing that I love is then writing a blog post about that, and like, oh well, here's how you can think of that thing that might seem really arcane and difficult in a much simpler way, and that's what basically my blog is about, and people seem to enjoy that.
Yeah, for sure. I love writing. For me, writing is the thinking. That's where like, it's sort of the constraints of writing something linearly. I think you have to get it to make sense and fit within those constraints, and that's the part of the process that I love the most. So I'm hoping you can maybe apply your way of thinking. One thing that I think might be exciting for people to hear about and learn more about from you is, you're in business now. You're running a business, and talking to you about business, I can see that you're kind of doing the same thing. You're sort of finding maybe not math, but like core tenets that you believe, and how you apply them to your business, which I think is really, really interesting and powerful. And just looking back, I'm curious, again, like everything you've learned since, when you look back on Quantopian, are there 2 or 3 like really important turning points that you can see that maybe there's a tenet that you have now that we didn't apply, or something maybe that we did apply and went well, or what you took away, and what you see as like kind of the key turning points for Quantopian?
Yeah. So for me, I've been extremely positively influenced by Quantopian, and in PyMC Labs, I basically just copy most of what I learned from you. And I guess the main thing is much more about the vibe of having an open, friendly environment where people want to show up, and really not working through like pressure and deadlines and competitiveness. And I'm just not a competitive person, so that style also resonated very well with me. But also in the environment at Quantopian, I just thought was brilliant. Like I just loved coming and meeting with colleagues, and just that vibe of like, we're all like doing this together, and everyone's collaborative and helping each other, and that you have to sort of set the stage for, right? And like lead by example. And I think you did that, and I'm trying to do that. So that I would say is like the main thing. The other things that I think are good lessons, and I think maybe at Labs it's a different setup where there's even more of now, is the transparency. So things were also very transparent. At Labs, they're like even more transparent, I would say, and I think that also works even better in terms of like even the comp is like very systematized and super transparent. Like every contract maybe just for context, PyMC Labs is a data science consultancy. So so everyone can see everything.
It's kind of amazing, actually. Like compensation historically, it's so secretive. There's been a lot recently to make it more transparent, for pay equality and things like that, which are great. And then also I think younger people especially are just like way more open about compensation. It's definitely like a big difference in generations, which I found like pretty jarring. Being from the prior generation was extremely reserved about talking about things like that, but seems a lot more stable in the long run. Especially like you said, if you lay it down from the beginning that it's open and people have that expectation, it seems really powerful.
And what that and the openness and everything does is it aligns the people in the company with the overall goal of the company. So whenever you try and create any sort of reward system internally for looking good, then people will try and look good and gain that reward system, and then usually that's where things go sideways and you have all these weird things happening. So yeah, taking those incentives away, and building that trust and goodwill with the key people. So from the first perspective, like I always wanted Quantopian just to do well, and whatever I could do to like make it more successful, I was more than happy to do. I didn't aim for that next promotion or anything. So that I think that's exactly what you want. And what opened the door for me was like that was even possible to build a company like that. I was like, oh no, it has to be this other way. Obviously, people have tried the other way and apparently it doesn't work. Turns out it does work. And now I'm wondering like why doesn't everyone do that? Like it just seems so much better, and the results also I feel are so much better. So
yeah, I think you have to start that way. I think it's hard to imagine transitioning an organization from having like ancillary games in place about levels and roles and titles, moving from that state to something that's flat, really flat, and totally aligned around the business is not easy. But I would say like essentially impossible because the game's afoot already. So the transition would become just part of that game. Actually, I want to ask you, like, do you feel that the people that you're recruiting are sort of like different in disposition because of the model and the transparency, that you're finding people that thrive in that environment and crave it?
Yeah, that's actually a really good point. Like one of the reasons why some companies might not do that is that they don't have the people that would thrive in such an environment. It is kind of different and special, and there's definitely a big degree of self-selection happening. And also at PyMC Labs specifically, because almost everyone is from the PyMC core development team, so that's the open source software, right? So everyone before that just is the type of person that would, out of their own motivation, without pay or anything, just like show up and be like, hey, I wrote this really cool contribution to your software project in my free time, right? I mean, that is already like a pretty
you're finding special people.
And like putting those people then in a environment where like that type of freedom and self-motivation is rewarded and there's no red tape, that's where those people thrive. But if now there were people who just like, oh, just tell me what to do and I'll do it. Like I couldn't even do that. Like so
you wouldn't know where to begin. Why don't you tell me?
Exactly.
So just turn back to Quantopian for a minute. Another kind of big question. So it didn't turn out the way we wanted, and I think it's fair to say that the investment strategy, failed. Right? We did a lot of things right, but in the end, we didn't generate the track record and the returns that we wanted. We didn't grow that part of the business. We had to pivot away from it. And I know you've thought about this really deeply while we were doing it. I feel from our conversations over the years that you've ruminated on it quite a bit. And so I'd love to hear why you think it didn't work. One thing I just want to add, because I've gotten a lot of feedback from people watching and reading my newsletter about the retro. It worked in a lot of ways. Did a lot of good things for a lot of people out in the world, for people that worked at Quantopian, for me. So I'm super grateful for it, and I still love it, and I love the experience that we had. But I also just like to be super candid. And the thing that we set out to do was to build this hedge fund and have a really hard Sharpe ratio strategy that generated great gross returns, and we weren't able to do that. And I think it's a very interesting question. I don't think it's like sort of like self-abuse to ask that question. So in that spirit, I'd love to hear like what you think happened and why, and what you thought about over the years.
Yeah. So I would start with what you also said, is that we did many things right, and starting with the community. Like I think that was just the most amazing aspect. Also because of the community, how amazing they were, and getting to know the people there, and how talented and motivated they were, and that
It's a big
that was
takeaway, right?
incredible.
There's so much talent in the world.
Yeah.
Like really amazing people.
So yeah, and I mean that was one of the core things that needed to be true for Quantopian to work is, there are people like that, right?
Yep.
And there are like hundreds of thousands of them. That was amazing. And then do those people show up to do the work? And like, yeah, definitely. And, and also I think it's fair to say that actually they did, they were capable of producing the type of things that we needed for the fund to succeed. So, but that I think really we cracked at the end, and that gets me, I guess, to like what I think took us too long to figure out.
Yeah.
So, one of them was asking the individual person, the community, to do too much. Just like, well, here, like build an end-to-end strategy with like the alpha signal and then the order execution and the right transaction and all of that and order timing. And if you look at big hedge funds, right, no one there is asked to do all of that, right? They're just like focused myopically on these individual pieces of that whole pipeline, which makes all the sense. And then as we got to, and I mean, we were learning along the way, right? And about risk models and everything. And the other problem I think was that there was always this delay in communicating what we learned to the community. And not necessarily by the communication delay, but rather changing the incentives, right? So one big incentive mechanism were the competitions. And changing anything there in terms of like, well, now it's different, and then teaching everyone about that. And and then there was like the 6-month delay in terms of the out of sample, right? So basically every new insight we had of like, oh, well, actually the community needs to do it a little bit different like that, with at least 6 months until they turned around that ship and got us the strategies that we could look at.
And just for context for everybody, the out of sample is we would sort of immediately collect strategies as people coded them, and then we were allowed to run back tests on everyone's strategy, but we would sort of freeze the code on the date that they wrote it, and then just wait 6 months for fresh data to accumulate. And that would be our out-of-sample test, which is like the ultimate litmus, right, for a predictive strategy. So I think almost here are like two different things: the contest and changing the incentives in the contest, and then like the 6-month lag before any change that we made to our process kind of worked its way through the algo production. Can you say a little bit more about what you're getting at with the contest? And what changes you saw there that were, I think you were saying there were changes that were, I think, productive to the contest.
For example, one simple change was, actually don't worry about the order timing, right? Just like always set it to this, like always set it to the close. And more standardizing, I guess. And don't look to not have too much risk exposure in this sector to like change the risk bounds. So that was a lot of things that we learned how to, for the strategies we needed. And then, those changes did make it through the contest, but
didn't make it to the fund ultimately.
So I was really happy with the setup we had at the end. So there we had a different type of contest that was way more low key, where it was just a forum post that said like, now we're looking for this type of thing. And here's the sample which you're not allowed to train on. And then we like have all these submissions just as like forum posts, right? So every forum post we could just make up totally new rules and say like, actually now it's this thing. So this whole thing.
And I think like the dialogue with the community was different as a result. Their expectation was it was going to change. Like every contest was different. And that was the expectation versus like the more boxed in. That's actually a theme as I look back, like over constraint. I think that might be like a personal like characteristic that I have that I sort of was putting into the company is to really structure things. I remember thinking a lot about crowdsourcing, and I thought a really important property for crowdsourcing was to standardize so that you could like collect a lot of answers.
I see.
Which I think there's some truth to that, but like if you're saying with this contest, we explained what we wanted and people submitted it, so you were getting, you know, sort of standardized answers, but you could iterate really, really quickly.
Yeah. I guess the more you productionize, the harder it is to iterate and change things. And I agree. I think that's a general lesson for all businesses. Like in the beginning, you don't want to automate. You just want the simplest processes possible because you should be changing them all the time.
Right.
Because you're learning extremely quickly and you want to implement those learnings as quickly as possible.
Do you think that applies to everything? Like, does that apply to software? Like when you make software, you make super high quality software. Do you have a similarly iterative approach there?
Yeah.
Like, are you okay with low quality up front?
Absolutely. So with PyMC, actually, that has changed now because it is like used by so many people. So what I have is a different repository called PyMC Experimental.
Okay.
And that's where we're like, oh yeah, I mean, maybe it has single unit tests, or maybe it doesn't even have any. Just the threshold to get things in there is much lower. We can move much faster.
Yeah.
And we allow ourselves to like push out API that we break all the time. And then once things stabilized, we take that nicely marinated code to port it over into PyMC.
I've heard that actually some similar kind of thinking for researchers at funds where during the research phase, they're, you know, methodically searching for signal or they're methodically exploring anomalies, and it's very slow, and you're very skeptical, and you know, you're doubting like any positive result because it's very improbable that there is something predictive. But then when they sort of find something that they can't falsify, they switch modes, and it's like, oh, we have a discovery here and we need to get this into production as quickly as possible. Which I think is really, really interesting. I think in quant hedge funds, that's one of the core engineering problems is to have this sort of like punctuated equilibrium where, you know, you have a production system and all of a sudden you might have to make like a dramatic change to it, you know, because who knows what the discovery will be. It might be data, it might be a technique, it might be like a different form of compute, you know, it could be anything. And so that's, I think, really, really big challenge for all funds. I guess just on the question of like, why didn't Quantopian work? I'm gonna paraphrase, see if I get this right. I think what you're saying is in research, in the end, you felt like it was working, but that we didn't move it into the fund fast enough.
Yeah. So, yeah, I think that's what I would say is we didn't get to try. So who knows? We won't know. Yeah. But I definitely felt towards the end that like, okay, well now like the different pieces are in place and we have to put them together, build the track record, but then there wasn't enough time on the clock. But also I think we were too slow to get to that point. Like, I don't know, it was like 8 years or something.
I think we were way too slow to get to that point.
Yeah. So like that is a reasonable amount of time to like figure that out, and for whatever reason we didn't get there. I would say another thing is that even though we did hire industry experts, that it's actually maybe a similar problem to the learning, where really having if we have had someone who like was expert in exactly like this what we're doing, then a lot of those learnings could have maybe happened faster. Even though, I mean, we did have experts, but still there was like a lot of iteration and research that needed to happen. I mean, also no one has ever done that. So
I think there's no one had done specifically what we're doing the way that we were doing it. And I thought, you know, one analogy or one analogous business was like Millennium with, you know, multiple independent managers. You know, another analogous business is World Quant with like, you know, global researchers and then a team of portfolio managers. So I think one thing in retrospect, I wish I'd been more, I think like more aggressively curious about is how those other businesses worked. Like day one of Quantopian, I wish I'd been much more curious about, how does Two Sigma work? How does Rentec work? How does Millennium work? What are the differences? And similar to what you're saying, like get to an intuition of like what are these different models and what sort of inputs do they expect? Because I think sort of an unnecessary, I would say unnecessary curveball deep into our process is, we were imitating or using the analogy of Millennium, right? Like a multi-pod shop, not literally Millennium. But copying the idea of like a multi-manager structure and thinking of the algos as a manager. And you and I had a conversation I remember very, very vividly. And the quote that like really kind of rocked my world was, that's just not what the data is telling us. Right? The data is not telling us that we have 20 strategies that are back testing with a sharper 4 out of sample. Right? That's not what we're seeing. We have different data. And I think that was one of the most compelling conversations I think I've ever had in business, because it was very candid. Delivery wasn't forceful, but it was very clear you wanted me to listen. And I did, because I think the way that you explained it was extremely intuitive for me. As like I'm not a statistician, and I'm not, the quant researcher. I'm just trying to build this business. But that was like very, very vivid. So for all the data scientists out there, it's a great way to explain when something's not working the way people expect. But it would have been a lot smarter if we had started with, and the other thing I remember from this conversation is like, what is the data telling us, right? And I think that's like a beautiful question and very memorable. And I think if I ever had the opportunity to be running a business where that's relevant, I always think of that, even now.
And again, I think there's a critical lesson for all businesses is that you need to be able to experiment and really find something that works and not build something which you think will work. Yeah, so because the other thing, and I also remember that when we were talking about the multi-manager thing, and we were finding some strategies like promising, and there was with Matthew Grenade in the room who was like, let's go to war. Yeah. And we were like, let's like actually commit capital to this. And I thought that was amazing. And I think it was the right move to like actually do it and just like try things out. That was very much in that framework.
I think that the spirit of Matthew's comment there was really, you need to try things. Yeah. And don't spend so much time like trying to figure out what will work before you try it. Yeah. Yeah, I definitely think that a weakness that I had, actually, ironically, I think it's ironic. I love making software. Love it. I love everything about it. I love thinking about it. I love planning it. I love implementing it. I like talking to teams about it. I like all the issues that come up while you're doing it. I love learning about new systems and capabilities and things like that. And that was a big part of my personal motivation with Quantopian, is I wanted to have a company where I was going to make software the way I wanted to make software. And that is not the business. That's like, that facilitates the business. That's not the goal. So I have mixed feelings about it, because on the one hand, people loved working at Quantopian because people love making high quality stuff. Yeah. Right. It's a joy. And I think we punched way above our weight in terms of who we got to work there.
And also, I mean, that's the other thing I think that we did excellently is like build the community and the software. I think that was just world class. Yeah.
Yeah, I talk to people who I respect a lot in quant finance, and they're just like Zipline, Pipeline, Pifolio. These things are so good, still so relevant. A lot of other companies have built their business on those components, which is, I really mean, this is awesome. That's why you open source things, but is also ironic. Yes. Yeah, I think the love for making software kind of led me to focus on certain problems that were like, I hate to admit this, but like were interesting from an engineering standpoint, maybe not the most important thing, or maybe like an overcommitment to like a certain approach. So that's definitely a huge lesson for me. I wanted to switch it up, talk about the present. You're talking about the past. although I get so nostalgic talking about Quantopian. I love it. But presently, you're running just like a kick-ass company. And we've gotten to talk about it a lot over the years as you were developing it and figuring out what it was going to be. But just to start, I'd love if you could just explain PyMC Labs. Like, what is it and why did you start it?
Mm-hmm. So I started it because I loved the project and the people that built that project. And that project is PyMC.
Yep.
So that was really the project that I started in grad school. And I joined. Other people started it.
I don't think I knew that. So you were working on PyMC when you were doing your graduate studies.
Yeah, that's where I got
So that
started.
is a long-term relationship.
Yeah, indeed.
Wow.
Yeah. And that was just like, so PyMC 3 was at that time a complete rewrite. I was there when John Salvatierre was the original author, like created, and I was like, this is just absolutely genius.
Yeah.
I want to join and help grow this, and then more and more people started joining, and then I started working with Quantopian, and it also was a great tool for the problems that we were encountering there. So portfolio construction and selecting the best strategies and weighing the in sample and the other sample. And
can you take a beat and just talk about, maybe explain a little bit more about what PyMC is, and then I think people will be very interested to hear like why it's so applicable to the portfolio problem.
So it is a statistical modeling package, and that allows you to build customized models. And for like at the very simplest, it might be just a linear regression, right? So you can write that, but and there are other packages that have a linear regression module, and then you can run a linear regression, and that's cool. But from that simple starting point, you can just build models that are way more complex than that. And the way that you like to build them is to think about the causal graph behind your data. Like, how do these different variables, my inputs, relate to my outputs through different latent things that I'm not observing? So in the context of the strategies, what we were observing were returns over time, right? And then what do we want to know? We want to know, okay, well, how good is the strategy? But it's correlated to the market, right? So we want to know the alpha and the beta. So how do we build that in? But then also there are different things that are happening to the returns over time. So they are, if you look at the volatility is changing over time, right? So 29 during the financial crisis, a huge volatility spike. And so you want to build that in, right? So you're saying, okay, well, I have a return series, and now I want the volatility to change over time. So you can actually allow the volatility to slowly drift over time. So you build that component in. And then the returns are also drifting over time, the average return. So you build that in as well. And so there's all these different properties in your data, and you can build specific mechanisms into your model that match those properties. And then you have a very rich model that explains your data very, very well and all the intricacies of it.
And the creative process is coming up with the elements of the model that you want represented, right? That's the human contribution to the system. Yeah.
And that's basically the difference to machine learning, where machine learning, you have some data and you just give it to the model, and the model itself, that's the job of the machine learning model, like a random forest, to figure out, okay, well, what are all the intricacies of that data, and how do I best maybe build a classifier out of that, like which features do I combine in which ways?
Yeah.
And in Bayesian modeling, usually you would do that same process, but you do it manually, using expert domain knowledge of how these things fit together. And that is more work, right? Because it's not automated.
Yeah.
But if you have that domain knowledge and you know how these things fit together, you can build a much more powerful model that really that then is also interpretable, right? So once you fit that model, you can actually see exactly what is happening to the volatility and whether your assumptions are correct. And
that's an interesting part
fit
of it,
together.
Another interesting difference to the machine learning approach, right? Where you can look at the model and explain what it is and what it's doing and why you're getting a certain result versus machine learning. What I've learned from you is often you have no idea why it's doing what it's doing. Are there certain domains that you think the sort of explicit modeling is the right approach, like a better solution than the ML? Like, and I guess probably more interestingly, how do you figure out which problem belongs to which solution?
Yeah. So there's certainly problems where machine learning is the right solution. So whenever you have something where you don't care about how the, say, prediction was made, and it, like, yeah, let's say it's just a black box predicting problem. You're like, oh, the only thing I care about is predicting this class as accurate as possible.
Mm-hmm.
For example, let's say image recognition. So there, I would never use a Bayesian model because usually I just want to know is that a cat or not. And moreover, the structure in the data is so complex, right? That it's basically you can't build a handwritten model to explain like all the different things that could happen in an image, right?
Yeah.
So people have done that, but it just doesn't work.
Yeah.
So there you need lots of data to train these deep neural networks to really find all the different statistical things that are happening in the visual world, which is a lot.
Yep.
And very complex. So there I would never use Bayesian modeling. I would use it for problems where the complexity of the data is not as high as it is for images, for example. And we have that really good understanding of what things are. So what is that? We call that the data generative process. How was my data generated from first principles to outputs? So and when I need that interpretability. The other concept which makes it not just statistical modeling but Bayesian modeling is that we also track uncertainty. So whenever you want to know not just, the Sharpe ratio is 1 and it's not 1.1 or 0.9, and the point estimate that you usually do if you compute Sharpe ratio with the classic formula just gives you a single number.
Yeah.
And then maybe that was just computed over 3 months returns, right? So you have really no idea how accurate that number is. Yeah. And in Bayesian modeling, you get a full distribution of all possible values and how plausible those values are. And there you would see like, if I were forced to pick a single number, then I would probably say it's 1.
Yeah.
But it could also be minus 0.5. I just have a lot of uncertainty around that.
Yeah.
So but the problem is when you have domain knowledge and when you need uncertainty, then usually Bayesian modeling is a good fit.
I think one of the things that I learned at Quantopian that really changed the way I think about everything is that everything's a distribution, and like there are relationships between the distributions, and you can have the same kind of linear regression on distributions, and sort of use the same type of simple modeling concepts, but that idea that everything exists in a distribution and like never really think just about the point value was huge for me. That was just like a massive, eye-opening, world-changing epiphany. Powered by Dr. Thomas Wiecki.
Nice.
I'd love to hear about PyMC Labs. There's a lot of things about it that I think are super interesting. One is I feel like you've kind of solved the open source motivation problem. You have a lot of people working on this library. It's super well maintained, and the people working on it are happy, and it seems very sustainable, which is hard to achieve in open source. Yeah. So I'd love, like, did you plan that? Did you think about that explicitly, or is that like a byproduct of other things that you did? Were you even worried about that when you started working on it?
It was definitely an explicit goal to have the company support the open source efforts. And I mean, that's what really started it all, and what the primary motivation for everyone is being able to work more on the software with the software.
Yep.
And only then, second to that is like the company. I mean, that's the vehicle to get there.
Yeah.
But it still wasn't obvious that it would work and how it would work. And there's definitely a lot of surprising things that I learned of how amazing open source can be in a business context.
Yeah.
And again, a lot of that inspired by Quantopian, where also I remember those discussions. Yeah, I remember those discussions very well, where it was like, so Zipline, we have this cool thing, should we open source it? And we were just like, okay, cool, why not? And like amazing things came from that.
Yeah.
And things that we back then didn't and couldn't have anticipated. And that actually is, for me, the most powerful thing. Is like by putting things out there, you really don't know what's going to happen, but usually it's something good.
Yeah.
So there is definitely some leap of faith that's required in going down that path.
Yeah.
But I found so many surprising, cool benefits to that that are also difficult to communicate. So I remember being on calls with some CEOs of bigger companies there that were sort of curious about open sourcing some of their things because someone else in the company maybe was really motivated, and they just kept asking me like, but how do I make money with it? I'm like, well, okay, so you don't sell software, but so they get developers and the contributions there, and then you get contracts and recognition, and then I explain like all these different intricacies, and he's like, okay, but how do I make money with this? And it is hard to wrap your head around, right? I mean, just like selling a product is obvious, the exchange, and the way that you make money with open source is like much more indirect and requires that more feedback loops to kick in.
Right.
But once they do, it's powerful stuff. The network effects are really strong.
That I definitely agree with. Like the credibility that comes from it. It's a brand, right? It's a brand among a really important group of people in business, right? Data scientists like know it and care about it and want to use it and want to understand it. I think the other thing that's interesting is it's complex how it plays out from the software to the business. But you designed a business actually that's, and I mean, this is a huge compliment, is very simple. You know, it's like elegant simplicity. Maybe actually you can just explain the model quickly.
So at the core, it's a service company. So it is just a consulting company. We have, the companies the clients would be just companies. A lot of them, but not all of them, are marketing analytics teams at companies like we work with HelloFresh, for example, or other big brands. Yeah, let's say they want to know more about their marketing attribution. How effective is the money I spend on Facebook ads? And that's a data science problem at the core. So we would start that contract, and then me and a whole bunch of other people in the team who are all open source, people from the open source world, and they're all subcontractors. So it's a very free-form model, and we pay hourly. So there's a time tracker, and then people really only work as much as they want to. So it's a very flexible.
It's very open source kind of ethos.
Yeah, exactly. So people are invited to show up and do as much as they want. And I mean, obviously, there are client expectations, right? So there is some more pressure to like do things in a timely manner.
Yeah.
But still, there's also some self-selection going on where there is, and also the fact that we're doing research, right? So you can't really put too much timeline on that, and also not too much pressure. It just doesn't help. You need insight to move things forward.
So you may notice we're in different clothes. The light's a little bit different. So here we are, day 2, recovered from a dead battery in the camera. And what we ended on yesterday was talking about PyMC Labs and the model for the way that people work. And it's a bright new day, so I thought we should just change topics, or extend maybe is a better way to think of it, and talk about Gen AI and LLMs and everything that's happening in that part of our world. And actually, my first question kind of builds on our conversation about your company, because I think one really fascinating thing about PyMC Labs is how you've found different parts of industry where Bayesian stats just like really work and are extremely effective, right? So like one example we've talked about is marketing analytics, right? And really understanding spend and things like that. And I'm just wondering where you see Gen AI and LLM, like where's that going to work? Are there applications you're really excited about for LLMs?
A lot of them. So it is gonna, I think, well, like I said yesterday, the situation where Bayesian modeling is not that powerful is where we have unstructured text. So and in general unstructured data. So that's where generative AI just excels. So images, text, and obviously then text is what opens up the door to a lot of industries. So healthcare would be one where Bayesian modeling is not really all that common. I mean, it is when you have lab data, but for everything that's patient records or things like that, where it's just a lot of text.
Notes, right?
Yeah.
Yeah.
It's going to make a huge difference there. But really, I mean, one of the other amazing things is that due to the LLM being able to write code, it can also do things in other domains. So it can also write Bayesian models. So it's not even that it's only for those domains where we couldn't before use other tools. But yeah, so I think that's also going to be really interesting. I mean, I don't know if any of us will be coding in 5 years.
I don't know either. I mean, I love coding, but I just don't know if it will be worthwhile after the code is going to be so cheap with ChatGPT. Also, it's pretty fun to code with AI. I mean, it's
the productivity boost is insane.
Yeah, especially early on. Like PyMC 3 is a great example. It's a complex tool. There's like a lot to learn. It'd be pretty amazing if you could talk to an expert, an artificial expert, and get models from it. Have you actually tried that?
Yes. So I've been working on like a GPT assistant that is working in that regard, because one of the biggest problems we have is that PyMC, even though we try and make it as user-friendly as possible, still is super difficult for beginners, and especially people who don't have any computer science knowledge, right? So business people, but those are usually the ones that we really want to learn about that tool and use that tool.
It's also where the domain knowledge is, right? To your point about like getting like the domain experts to produce the models.
Exactly, yeah. So
are you going about it like really directly? Is it like you talk to ChatGPT and it codes the model, or is there something like?
So there's different levels that I think we can integrate it. So one would be just, and you can do that today. You're just like, well, here's my data. Now build a PyMC model, and then it'll do a pretty good job. The other thing that we started exploring with, is a more also domain-focused GPT assistant.
Okay.
So there's with Niall Olden, we built it's called GPT MMM. So MMM are marketing mix models, which are the thing that does the attribution of marketing dollars.
So that's really specific.
Yeah.
Okay.
And it's a huge field in marketing analytics to understand how effective your advertising is. And that essentially is an assistant where you can just ask questions, and it is it knows about our source package PyMC marketing. So that's like a Bayesian model for building these marketing mix models.
Yep.
And GPT doesn't know about it because it came out after, even like with the retraining. Currently, it doesn't know anything about it. So we fed it the API and all the docs.
Oh, cool.
And also trained it on like certain prompts. We're like, how do I include TV spend in my model? And so
how'd you do the training on the prompts? How's that work?
So you just put it into the instruction window. So you're just like, here are a couple of answer responses that I want you to do. You can also upload other text data.
Okay.
And
did you give it the code of PyMC marketing?
We haven't, but we gave it the notebooks that show the API.
Okay.
But I actually think it would be a good idea to give it the whole code,
so that it knows the implementation. Yeah.
So that works really well and is almost like interactive documentation.
That's funny you said that. I've been using it to learn a framework called Fast API for web services. I realized like when I was talking to it, essentially I was just asking like, can you write a how-to just for the specific thing that I'm trying to do right now, you know, with knowledge of like the classes that I've written already. And so you just get like perfect help documentation over and over again. Yeah. Super satisfying, although just shy of what I really want. I don't know if you feel the same way, but what I really want is to talk to ChatGPT and then be able to watch it, you know, edit all the files in the project and like understand the full structure and everything like that. What do you think is, I don't know if you've had the same experience, but when I used it, what I find is it's amazing at that like, directed help documentation. And it's amazing at, you know, refactoring a single Python file. But then if you wanted to like make a project, it doesn't have any idea what you're talking about.
Yeah.
So what's the difference between those use cases that, you know, it's so good at like help documentation in a single file, but then it gets like lost somehow in the structuring of things?
Yeah, I think one of the struggles is still to overcome that there is to generate a lot of text coherently in like the more structured approach. Like, usually if you do it just file by file, it actually does a fairly decent job.
Yeah.
There's also a really cool project called GPT Agent.
Okay.
Where you have one GPT instance have the overall roadmap, so that the only task of that is to say, well, what is the overall structure? I need a front end, I need a back end, these other files, and how I want to set it up. And then for every subtask, it'll spawn new GPT agent. And
so that thing just has a narrower context.
Yeah.
Child agents.
Yeah. And that way, what you would normally do manually is like, oh, like let's do this chunk and this chunk. There's just that is replaced with another GPT.
Yeah.
So that those projects I think are just super fascinating.
Yeah.
And that's, I guess, coming back to the open source discussion, where open source really is leading the way. So that's the other thing I've been really excited about, is how active and innovative the open source community is when it comes to these large language models. And well, the models themselves, like there's a lot going on there, but then also just the tooling around that.
Yeah, can you talk more about the tooling? Because like this agent thing you're describing, like I want to run upstairs and like start coding right now. Using it, that's amazing. I'm just curious, like what you think is going to happen with the tooling, because I think I told you the story already, but I had this experience where I was working on a project to write an article based on a video, and that was all about managing the context window. You know, like the engineering problem was like chop up this text and figure out how to squeeze everything into the 8,000 tokens that it supported. So I spent probably like a weekend figuring out that problem, and then on Monday, you know, GPT-4 with 128,000 token window came out. It was totally useless. I was still very happy, but you know, there's such like rapid advancement in the engine, and it's so general purpose. I mean, it's the most general purpose tool that's ever been created. So like, which of these like tooling projects do you think like have longevity and should be like ones that, you know, we should be learning to use?
Yeah, that's impossible to answer. And that's where I used to get stuck on being very excited of building projects is how easy, well, and also being interested in startups, right?
Yeah.
So I remember when all these startups came out where like, oh, well, GPT can't handle PDFs. So now we're a startup that allows you to analyze your PDFs with AI. And then they were just like nonchalantly, oh, well, now you can upload PDFs and like all of those people, I guess, obsoleted. And that can happen any day in whatever direction, right? We don't know what they're gonna ship, and they seem pretty good at shipping stuff. So that is difficult to anticipate. So and the same thing with the GPT agent. Like I think that's also just gonna be for a short amount of time.
It's like scaffolding to get to like that next level.
Yeah, and like GPT will be able to also handle the more general, like the broader structure, and you don't need like sub agents. So it's tricky because it's moving so fast.
Yeah, but that's what makes it like so fun to keep monitoring it. Yeah. I mean, I can't remember anything in my career that is this exciting.
Yeah.
Like every release is just jaw dropping. So I think a couple nights ago when we had dinner together, you this great explanation of how the neural network works. You're explaining images, and I think everybody would just really appreciate that explanation of like the steps, in the layers of the neural network was just made it so clear to me. So I was hoping you'd try to recreate the magic of your explanation.
I could try. So for me, it's still very difficult to wrap my head around how these models appear so intelligent when all they're doing is a whole bunch of matrix multiplications, and the individual modules that it's built out of, these layers in the transformer architecture are not that complex. Like there's not a lot of machinery. So there's a self-attention mechanism and then a layer of like densely connected neurons, and then you just keep stacking that in all directions and train a lot of data. So how does that produce this amazingly insightful outputs? I don't know. So the best I can get there is from looking at vision models that are just also, have been around for much longer and success and like this type of magic before.
Yeah.
And it all started with object recognition. And one thing that helped really me in terms of intuiting how it's doing what it's doing, and is through learning these different abstractions at different parts of the layer.
Yeah.
So, and interestingly, in these models, it also really is analogous to how the brain is doing it. So you train a very deep network to do object recognition on images. So you feed it pixel values on the one side, and out comes there's a cat on here.
Mm-hmm.
And then there are these hundreds, thousands of layers in between. And you look at the first layer, what that is learning, and that is learning to detect edges. So just super simple. And then you look, and then you look into the brain, into V1, the first layer of where the retina feeds into the brain, and that is detecting edges.
Mm-hmm.
And then you look at the second layer, and that is detecting corners. So just two edges together. And then the third layer is connecting corners together. So you have like shapes.
Yeah.
And you just keep going up, and it gets more and more intricate to where you have neurons that detect eyes or cars or things like that.
Yeah.
So that I think is super helpful in how these layers are learning increasingly higher order, more abstract representations.
Yeah.
And I'm sure there's research, I haven't seen it, but the same must be happening with text as well, where you start with like, okay, well, different parts of different words, so they belong together. And I have a attention mechanism where I can filter out the relevant information, and then that builds into more sentence structures, and to where there's going to be very high level abstract thoughts being encoded in the higher levels,
right?
And ideas, right? And that I think is a little bit more difficult to intuit, but but nonetheless, like I think that is, for me at least, the best way to think about it.
What I think for text, like that last level of like concepts, that's sort of, I think, the limit for me in terms of imagination of like, okay, that's kind of what I do. Like I there are images in my mind, or I think of concepts and then they turn into words.
Mm.
So I can kind of empathize with the machine, I guess. But I think one of the other things you said is there's no limit. You can just keep adding layers to this thing. So is there, there's something I haven't experienced, which is like what comes after conceptual thinking, or is there something like more higher order still from that?
Yeah. I think that's really interesting. I just had the thought where like, well, yeah, there's emotions, right? Like, like let's say there's a neuron that is like love, right?
Yeah.
And like that concept, I guess, can have so many different things which you can generate from it, right? So that would be a very high level, very abstract representation. But then, so once you go higher than that, that might be where our human minds just stop being able to work, like create similar high-level concepts, right?
Yeah.
So maybe it's finding these concepts that are even higher order than what we ever realized.
Right.
And I think that's also where it becomes interesting in terms of like how far can this superintelligence become. And there's currently all this talk about Q star and what that is, and no one really knows. But what is interesting?
Does no one know? Like the internet doesn't know what Q star is?
No.
It's a big mystery.
Yeah. It was just let's weird leak. I mean, maybe by the time this is out, we'll know more. That'll be interesting to see. But one idea that I heard that I think is very, very interesting. It's certainly one direction that we'll have to go into, whether Q star is that or not. But that currently GPT-4 any LLM is just trained on text data, existing text data. So that will be limited in a way to what the smartest people have written about. So from that alone, it is difficult to imagine how that could exceed human abilities by a lot. However, we have seen AI supersede human abilities with the AlphaGo, exactly. Yeah. And the way that they did it was that they first trained it on human Go games and achieved human ability, but then they had the AI play against itself and always just select the one that did a better job. So that way it was able to exceed superhuman abilities. And if you look at that plot over training, how well it did, it sort of shoots up at first, which is very classic, and then gets to the human level and then goes beyond the human level and but like plateaus with like a pretty healthy safety margin above that. Okay. So you can keep training, but that might be the upper limit of what's possible with Go. But we have no idea what that is for LLMs, right? So we keep training LLMs in a similar way where we just like sort of figure out a way to play against itself. Who knows whether human ability is here and we shoot up here or whether it'll plateau shortly after. My hunch is that it'll just like keep going for a very long time. And then
we'll see what happens.
Yeah.
I the interesting thing about the LLM, like the that like it's not really adversarial, it'll be like conversational, right? They're gonna like all these AIs are gonna talk to each other and develop their knowledge. I feel like the hallucination problem is gonna be like extremely big challenge, right? Because you can just imagine it like fanning off in all these different directions that describe not this universe, like maybe some other universe.
Definitely, it's a much more challenging problem to have this.
There's no
play
rule
against
set,
itself.
right?
There's no rule set. There's no real way to evaluate. Oh, this is more intelligent. This is better than the other thing. If they crack that nut, it would be another game changer.
There's probably I would think that there's lots of ways to measure, and it'll take a while to find the one that's like extremely effective that gets you like the result you want, right? You'll be able to figure out who's which of them is coherent, which of them is like agreeing with facts, stuff like that. Yeah, it's just I don't know. I really feel like we're living in the future with all of this stuff. So speaking of the future, I'm wondering like what you're looking forward to. You have this like amazing business. There's all of these really super relevant breakthroughs happening. That really it seems like hand in glove for the way that your business runs, where there's just like infinite demand right now to understand like what is an LLM and how do I use it and what does it mean for my business. I feel like every single person in the business world is asking that question. Every person in every field is asking that question. And so, you have to be excited. I mean, it's like such an exciting technology, and it's a really great opportunity for you and your company. So I'm just wondering like what you're looking forward to, how you're going to pursue it, what's it going to look like.
Mm-hmm. So we are super excited at PyMC Labs about these technologies, and at the very beginning, there was a little bit of hesitation because, I mean, at heart, we're still Bayesians, and comes this other approach that like is taking away the spotlight. But I'm really excited about building bridges in both directions. So one is we just talked about the GPT-MMM, GPT Bayes, where you can have that be an assistant to build Bayesian models more effectively, explain things more efficiently, and we have built tools around that, and we're gonna push out more. But then there's also the other side. I'm really interested in bridging, where we obviously know a lot about the computational statistics behind that and the open source nature, right? This is what we're do, and using these two things together to help companies achieve technological innovative breakthroughs. And I'm looking forward to working in that domain as well, where we help companies who might be looking to have an in-house LLM or use LLMs more effectively, and leverage our skill to that domain.
And what kind of companies do you think should be thinking about having their own LLM? Like what are the sort of like criteria?
I think definitely whenever you have in-house text data, like that's going to be a really interesting use case, and building in-house experts, train it on your internal code base, and have it be one additional code in the team, like unit tests. But certainly other things. I just heard about a startup in the healthcare space that is looking for an unstructured data. So one thing that I'm also really excited about is the breakthroughs in the psychiatry. So that's an area I did my PhD research on. And one of the best things to have happened there in the last 50 years is the rediscovery of psychedelics for treating depression. So MDMA, ketamine, DMT are just incredibly effective at treating depression, PTSD, and a lot of other things. And there's still a lot of very nebulous insight about that, and but there's a lot of people who are writing about the experience with that. So you can train an LLM on that data to basically get maps into what effects these drugs have, and basically create a map for that. So there's all kinds of creative ways to do that. And then of course, every product that you build, it almost seems like if you just like have a more direct way rather than like clicking buttons or writing a custom language just to use English. So that's, I guess, the breakthrough is like the what will they tweet, the hardest programming language of 2023 is the English language. And that's true. So everyone can just program anything and get much more direct feedback. So I think whatever the product is, UX will be enhanced if you allow for tools like that.
I totally agree. I also think it's going to be cool to see the creativity of how people sort of imbue intelligence into all applications. It's just like such a incredible capability to have embedded in your app. To be able to take like a English query or to ask advice for the user at any moment. So I just wanted to close on a question, kind of like on behalf of the audience. But if you think of the audience, there's a lot of people in academia, there's a lot of people in finance, there's a lot of people in engineering, and I'm just wondering like what advice you would have for them right now. Like what should they be studying and trying to learn? Like what are the right things that they should be trying to pick up and focus on?
I think I just say what I'm focusing on, which is that it will indeed be very difficult to see the impact that this change is going to have on AI. And the what makes the most sense to me is to really learn these tools and use them to the most effect, in order not to be on the side of those people that will just be obsoleted by that. And what is interesting is that it's happening in a very different way, I think, than most people intuited, where it was like, like more the blue collar jobs will be the first to go, but actually now it seems like the white collar jobs, like education, medicine, law, all these type of things where you just will have a pocket assistant that knows everything all the time and is free. That's pretty hard to beat. Coders, I mean, technology, right? That's like at the forefront because everything already there, everything that's happening on the computer is going to be the most easiest to grab. Yeah. So maybe the answer is learn how to fix plumbing.
Yes. Yeah. Massive shortage of plumbers in the United States. Actually, that's one of like the best fields to be in for the next like 20 years.
Yeah.
What I think is interesting is I don't think we realize how limited our collective like human civilization view of our potential is. You know, we're like really focused on this tiny speck in the universe. It's a big universe.
Yeah.
So my hope is that if we like break past that, you know, that we realize like there's so much more that we could be pursuing, you know.
And I think that's the optimistic view. So yeah, I think those my hope is, and in the past I think that's usually how it happened, is those jobs will not go away, that you just become extremely more proficient in it. So everyone's productivity will go up tremendously. I already see that with writing code.
Your ambition just goes up. I mean, like the things I'm trying to do in coding now, I never would have attempted, you know, a year ago.
Yeah, exactly. So that is definitely the path to the promised future.
Right. Yeah, it might turn out that like the savior of humanity is like the hedonistic cycle where we're just like never satisfied.
Yeah, that has worked in the past pretty well.
Pretty effective.
You can always rely on that.
Well, I just wanted to say thank you. It's been so fun to get to hang out with you. Thank you so much for being like the first in-person guest on the Quantopian show. And I don't know if there's anything else you want to share that's going on in your life, or anything you want to share with the audience, but just want to say thank you.
Yeah, no, that was a lot of fun. Thanks so much for having me.
All right. Thanks, man.
Thanks.